Okay, so we're beginning. Goal 1-1 on understanding the real number system. Natural numbers. Natural numbers are those numbers that you learned to count with back when you could start speaking. Okay? So think about it. What's the first number you learned? 1. They didn't say -4, -3, 0, 1/2. You learned 1, 2, 3, 4, which is how you should start learning to count. Because that is our one-to-one correspondence. That's how we start learning that when you have those Cheerios sitting on your high chair, way back when, and we go 1, and we scoot it 2. That's when I started teaching my kids to count. As soon as I could start seeing things and speaking, that's when we learned to start counting. So natural numbers. Even though this set is infinite, it goes on forever and ever, it's the smallest set we have. Okay? Whole numbers. We had one little number, very important number, 0. Oops, that looks like a 7 almost. And again, infinitely on and on and on. Then we have our integers. And our integers are our negative numbers also. So infinitely in the negative direction. And still in the positive direction. But no fractions or decimals at this point. None of those yet. Then we have our rational numbers. This is where it starts getting a little tricky. Rational numbers are any number that can be written as a fraction. Any number that can be written as a fraction. So if it's a fraction, it's rational. 2/3, 1/5, 21/17. 34/9. 11/48. Fraction. It's rational. But what about decimals? There are some decimals that are included here. Some. The ones that are included are terminating, or repeating decimals. And the reason they're included is because they can be written as fractions. The other day when Mr. Stevenson gave you your lesson on note-taking, everything I write down is important. I'm just going to tell you that. But if I get going and you need me to slow down, back up, something, please just ask, okay? So again, terminating or repeating decimals. Terminating decimals are like 0.25. And the reason that fits in that category is because 0.25 is also equivalent to 1/4, a fraction. 0.33333 repeating is a rational number because I can take that and write it as 1/3, a fraction. So if you can write it as a fraction, it is rational. Which means, what are irrationals then? Irrationals are going to be non-repeating, non-terminating, non-repeating, non-terminating decimals. An example of that would be, someone, anyone? Non-repeating, non-terminating. You know this. Think circle. Think apple, pumpkin, pecan. Yes?
Pi.
Pi. Pi is an example of an irrational number because it is a decimal that goes on forever that does not ever repeat or ever terminate. And then another example I want to give you on this are the other kind. The square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7, the square root of 8. Anything that's a non-perfect square. Like the square root of 4 is 2. The square root of 3 is 1 point something, 7 something probably. But it's a decimal that goes on forever and ever, does not stop, does not repeat. You cannot write it as a fraction. And then our real numbers are all the numbers that we're going to work with. So we'll just say for right now that that's all numbers. There is a complex number system. That's an Algebra 2 subject, though, Algebra 2 concept. So we're not going to worry about it right now. Okay, a question about any of my definitions. So I'm not going to ask you to memorize those. I don't ever ask you to recite or script out a definition, but you got to know those. Now I'm going to take that information and put it into a diagram because I'm going to show you how we're going to use it. So we're going to start at the top with real numbers, which we will abbreviate with an R. That will go in one of two directions. It will go rational, which will make RA, or it will go irrational, which will make IR. So that way we don't have to write all those words out. So your real numbers split. A real number is either rational or irrational. Can't be both. Irrational ones, done. That's as far as I go. Rational ones, I can break up to smaller sets. My integers, that'll be I. My whole numbers, the symbol for number, for pound, for hashtag, it's all the same thing. W, and my natural numbers, N. So there's my little chart. So, two things. If you can know the definitions, what numbers fit into them, and you can visualize this chart, like start looking at it once in a while and start visualizing. Like if I just said, okay, I want you to draw that chart for me, that's what you want to be able to do. Okay, I'm not going to ask you to do that, but that's what you want to be able to visualize, the way this chart looks, because it's going to help us answer the kinds of questions I'm expecting you to do. Okay? All right, so it says, list all categories the number is part of. So this is how, if I were you, I would approach this. Start at the bottom. Start at the bottom. Is 5 a natural number? Think about that definition. It was those counting numbers, so yeah, it's natural. If it's natural, that means it's also everything above it from this chart. It's a whole number, it's an integer, it's rational, it's real. So you find out at the very bottom of the chart where it fits, and then it's everything above it. So it's natural, whole, integer, rational, real. This is one type of question I'm going to be able to ask you about using that chart and those definitions. Listing the categories that it fits into. Okay, so -7. So I'm thinking I'm visualizing this. Right now I'm going to show it to you, but you're going to visualize where does -7? No, not a natural number. Not a whole number. Yes, integers are my negatives. So it fits there. So if it's an integer, it's also rational and real. So integer, rational, real. Three-fourths. By definition, a fraction is rational. It says any number that can be written as a fraction. So 3/4 is rational and real. These three things in our chart, there are no decimals or fractions here. That doesn't start until rational. I was saying rational and I was writing fractions, so I wrote fractional. Boy, that brain works in a funny way sometimes. All right, 9 pi. When you see pi, or you see a decimal that goes on forever without repeating, those are irrational. There are only two things that fit in there. So irrational and real. Everything's real. That's the answer for every question, because all our numbers are real. 9.375. You just got to figure out which decimal that fits into. Rational or irrational. So know your definitions. Rationals are the kind that stop or terminate or repeat. Irrationals go on forever. So this one stops. It's rational, which means it's also real. And then 0. So I think about my little chart. Where does this fit in? So I start at the bottom. Don't start at the top. That's harder. At the bottom. Natural number. No. Whole number. Yep. And then everything above it. So whole number, integer, rational, and real. All right, so this is one type of question that I'm going to want you to do with that information about the real number system. Okay? One type of question that I want you to be able to do. It takes a little getting used to. You're going to have to look at that chart. You're going to have to know those definitions to be able to answer them correctly. The second type are true-false questions. And this is a matter of knowing the definitions. It also means you got to pay attention to this word in front. The quantifier. How many are we talking about? Because that makes a difference. All right, question 1. Every integer is a whole number. Integers. Negatives and positives. Whole numbers. Not negative, not fractions or decimals. So that's going to be false. Because -5, as an example, is an integer. That's not a whole number. I will not ask you to give me an example to prove it false. You just tell me true or false. You don't have to give me a reason. Every real number is rational. That is false. Because remember that little chart. Think about your chart. It's real at the top, and then it goes one of two ways. It goes rational or irrational. So not everyone can be that. So this is false. That word makes the difference there. Some irrational numbers are integers. Okay, so irrational numbers are decimals. Integers, not decimals. So false. All natural numbers are integers. Okay, so let's think. Natural numbers are the very lowest thing. So natural numbers are everything, but irrational. So true. Some whole numbers are irrational. So whole numbers are not decimals. Irrationals are only decimals that go on forever. So this is false. Every decimal is rational? Nope. Because if it goes on forever and ever, it's irrational. So decimals are either rational or irrational. So if I change that word to some in the front, then that's true. But every, no, not going to happen. And the last one. Some fractions are integers. Fractions, integers are not fractions, so false.